It's January 2026, and halfway across the world, something massive just happened that most people have absolutely no idea about. China just crossed a technological threshold that's going to reshape global power, rewrite supply chains, and fundamentally change the chips that power every device you own. And here's the crazy part. They did it faster than anyone predicted. Seriously faster. We're talking about acceleration that shocked even China's own government planners. China just hit 35% chip equipment independence, and this isn't just another tech headline buried somewhere on a tech blog. This is a moment that's quietly rewriting the rules of the entire global semiconductor industry. And if you care about technology, geopolitics, your career, or your wallet, you absolutely need to understand what this actually means and why it matters exponentially more than most people realize. For years, we've heard about chip wars, trade tensions, and America's desperate attempts to keep advanced technology out of Chinese hands. Journalists, analysts, and government officials were all convinced that if America just restricted sales of chip equipment to China, they could slow them down indefinitely. But what if I told you that those restrictions didn't stop China? They actually accelerated them? What if the very sanctions designed to cripple China's chip industry ended up lighting a fire under their ambitions and forcing them to become completely self-sufficient? What if America's containment strategy backfired so spectacularly that it's now helping China potentially overtake American technological leadership? That's exactly what happened. And the implications are absolutely staggering. We're talking about a potential shift in global technological dominance that historians might be studying for centuries. Think about it this way. Making semiconductors is insanely complicated. We're talking about machines so advanced, so precisely engineered, that only a handful of companies on Earth can make them. American companies like Applied Materials have dominated this space for decades, basically holding a monopoly on the equipment that builds the chips that run the world. These are the kind of machines that cost tens of millions of dollars, require PhD-level engineers to operate, and represent decades of accumulated technological expertise. A single semiconductor fabrication plant, a fab, might spend $500 million or more on equipment, and almost all of that money went to American, Dutch, and Japanese companies. But China just decided they weren't going to accept that arrangement anymore. They decided they were going to build their own, and they're winning. Not just competing, winning. They're not just keeping pace. They're starting to lap the field. Let me take you back about 10 years to paint the full picture here. Back then, China was almost entirely dependent on imported semiconductor equipment. We're talking about 95% or more of all their semiconductor manufacturing equipment coming from foreign suppliers. If you wanted to build a chip factory in China, you needed machines from America, from the Netherlands, from Japan. You had zero choice. You were completely at the mercy of Western supply chains. China's entire tech industry was basically held hostage by American export controls and the decisions of foreign governments. The moment tensions flared up, the moment a trade war started, the moment America decided to weaponize technology, which, by the way, they absolutely did, especially under the Trump administration, China's ability to manufacture chips could be shut down overnight. You couldn't even upgrade your existing equipment without government permission from Washington. It was a terrifying vulnerability for a nation trying to become a technological superpower. It was like building a house on someone else's land. At any moment, you could be evicted. But here's where the story gets interesting. The Trump administration, and then Biden, they imposed increasingly strict sanctions on Chinese semiconductor equipment imports. They were trying to cripple China's chip manufacturing capacity. They were trying to prevent China from accessing the tools needed to make advanced chips. But what they actually did was light a fire under the Chinese government's backside and force them to innovate. They forced them to invest. They forced them to get serious about becoming completely self-sufficient. And China responded in a way that surprised even their own planners. The response was swift, coordinated, and shockingly effective. Fast forward to 2024, and China had already jumped from basically nothing to about 25% self-sufficiency in semiconductor equipment. People noticed. Analysts started paying attention. Investors began to understand that this wasn't just Chinese government rhetoric, but even they weren't ready for what came next. In 2025, the acceleration was absolutely insane. By the end of 2025, China didn't just hit their government target of 30% self-sufficiency. They blew right past it. They hit 35%. In a single year, they increased their self-sufficiency by 10 percentage points. Think about that. That's not a gradual progression. That's a sprint. That's the kind of acceleration you see when an entire nation mobilizes resources toward a single goal. And the people most shocked by this? China's own government planners? The people who set the targets were caught completely off guard. They set a 30% goal for end of 2025, thinking that would be ambitious, thinking that would be a stretch goal that would push companies to innovate. Instead, their own companies crushed it. They exceeded it by a full 5 percentage points. When your government officials are surprised by how fast their own technology is advancing, when the actual results outpace official projections, you know something extraordinary is happening. Something has shifted in the fundamental dynamics of the industry. But let's get into the real meat of this, because here's what makes this so dangerous and so fascinating from a geopolitical perspective. China didn't just increase quantities of equipment, they started solving the really hard problems, the impossible problems. They started tackling what engineers call the bottleneck technologies. These are the most difficult, most specialized pieces of equipment that only a few companies in the world can make. These are the things that require decades of research, billions in R&D, and basically impossible levels of precision engineering. These are the tools that literally define whether you're a cutting-edge chip manufacturer or whether you're stuck making last-generation technology. In early January 2026, just weeks ago, China made an announcement that absolutely shocked the semiconductor industry. The China National Nuclear Corporation and the China Institute of Atomic Energy announced they'd successfully developed and validated something called the Power 750H. Now, that might sound like a random name, but this is huge. This is China's first domestically produced high-energy hydrogen ion implanter. For decades, this kind of equipment was dominated by American companies like Applied Materials and Axcelis. These machines are essential, absolutely critical, for manufacturing power semiconductors, the chips that go into electric vehicles, power supplies, renewable energy systems, industrial equipment, everything you can imagine. These are the chips that make the green energy transition possible. These are the chips that make EVs work. Every electric car that's going to dominate the roads in the next decade needs these chips. And now China can make the machines that make those chips. They've broken through a barrier that was supposed to be impenetrable. This is the kind of capability that's supposed to take American companies decades to achieve. And China just did it in a few years. But it gets crazier. Around the same time, China made another breakthrough that shook the entire industry to its core. SMIC, which is China's largest chip manufacturer, announced that they'd achieved something that many experts thought was impossible without Western technology. They successfully mass-produced 7-nanometer chips without using EUV lithography. Now, what does that mean in normal language? It means they found a way to make incredibly advanced chips using completely different technology than everyone else uses. While the rest of the world depends on EUV lithography machines that cost hundreds of millions of dollars and are only made by a handful of companies, China invented a multi-patterning technique that doesn't require EUV at all. This means they completely bypassed Western export controls. The equipment they're using isn't banned. The techniques they're using aren't restricted. They're not breaking any rules. They literally figured out a way around the entire sanctions regime. They found a loophole in the geopolitical strategy designed to contain them. It's like the sanctions were written to prevent you from using one tool, and instead of trying to steal that tool, they invented a completely different tool that does the same job better. Think about that for a second. The whole point of American export controls was to prevent China from making advanced chips. But instead of stopping China, they just forced China to invent new ways to make advanced chips using different techniques. It's like trying to block someone from walking through a door, so they build their own window. Except in this case, the window they built actually works better than the original door. It's more innovative, it's more adaptable, and it proves that China doesn't need to copy Western technology. They can innovate around it. Now, you might be wondering how China pulled this off so quickly. How did they go from 25% to 35% in a single year? The answer is actually pretty straightforward. Money and will. Absolute unwavering national will combined with basically unlimited government funding. This isn't money allocated and then distributed through normal bureaucratic channels. This is money mobilized rapidly, focused on specific breakthrough areas, deployed without the normal delays and inefficiencies. China's Ministry of Industry announced an additional $50 billion in semiconductor subsidies for 2026 alone. $50 billion in a single year, just for semiconductors. Think about that number. That's more than some countries' entire annual budgets. If you think about it in total, since 2020, China has spent about $150 billion on semiconductor subsidies. That absolutely dwarfs the American CHIPS Act, which allocated only $52 billion total to revive American chip manufacturing. And that money is spread over years. China's spending is annual. This is China essentially saying, we're going to spend whatever it takes. Money is no object when national technological independence is at stake. Money is just a tool. The goal is sovereignty. But it's not just about throwing money at the problem. China is also pursuing talent like their lives depend on it. And I mean that literally. The stakes are existential. In the last quarter of 2025, more than 3,000 Chinese engineers and scientists repatriated from Taiwan, South Korea, and the United States. Think about that number for a second. 3,000 people. These aren't just random tech workers. These are people with decades of experience in chip manufacturing, people who worked at TSMC, people who worked at Samsung, people who worked at Intel, people with the crown jewels of semiconductor knowledge in their heads, people who have spent years, sometimes decades, solving the most difficult technical problems in the industry. And China is luring them back with salaries 5 times higher than they were making abroad, combined with equity stakes in state-backed companies. They're literally buying the expertise they need. They're importing the accumulated knowledge of the global semiconductor industry. Here's what makes this even more strategic and frankly terrifying for the West. These people who are coming back, they're not just bringing their skills, they're bringing institutional knowledge, the kind of knowledge that can't be written down in documents, the kind of knowledge that lives in the brains of experienced engineers. They're bringing the culture of how advanced chip manufacturing actually works. They're bringing the problem-solving mentality that comes from working at the most advanced chip companies on Earth. They know the pitfalls. They know the shortcuts. They know where to invest research effort because they've done it before. They've solved these problems once already. They know what works and what doesn't. And they're using that knowledge to accelerate Chinese companies up the learning curve at an absolutely breakneck pace. They're compressing decades of development into years. But here's what really terrifies Western tech companies and governments, the implications of this. If China reaches 50% self-sufficiency, which honestly feels inevitable at this point, suddenly Western sanctions become way less effective. If China reaches 70 or 80% self-sufficiency, Western companies lose leverage entirely. You can't embargo someone if they don't need your products anymore. Right now, America has enormous power over China's chip industry because America controls critical nodes in the supply chain. But that power is evaporating in real time. It's literally disappearing as we speak. And the timeline is accelerating. We're not talking about something that might happen in 20 years. We're not talking about some distant future scenario. We're talking about something that could happen in 3 to 5 years, maybe less. We're talking about this decade. We're talking about the 2020s. At the current rate of progress, China could conceivably hit 50% self-sufficiency within a couple of years. Maybe 2027, maybe 2028. And once you hit 50%, the psychological and strategic flip happens. You're no longer dependent on foreign suppliers for half your equipment. You've crossed into a zone where you have real options. You can negotiate from a position of strength. You can diversify your suppliers. You can say no to unreasonable foreign demands. You can push back on sanctions. You can develop your own standards instead of adopting Western standards. You've transformed from a desperate buyer into a strategic player with leverage. That's the game-changing moment. That's when the geopolitical dynamics shift fundamentally. Now, what does this mean for you personally? What does this mean for the tech you use, the devices you own, the prices you pay? It means several things, and most of them are pretty significant. First, it means the chip war isn't over. It's actually heating up. America and its allies are going to have to respond. They can't just sit back and let China become independent. There will be policy responses. There will be diplomatic pushback. There might even be more extreme sanctions. But here's the thing. Every sanction China faces just accelerates their motivation to become more self-sufficient. It's a vicious cycle that's actually working in China's favor. Every restriction pushes them harder toward independence. Second, it means the global chip market is bifurcating. We're moving into a world where there's essentially a Western supply chain and a Chinese supply chain, and they're going to become increasingly separate and incompatible. Companies are going to have to make strategic choices about which ecosystem they want to participate in. Want to sell to America and Europe? You'll have to use Western chips and Western equipment. Want to compete in those markets? You need to integrate with the Western supply chain. Want to sell to China and the developing world? You can use Chinese chips and Chinese equipment. You can go all in on the Chinese ecosystem. This is going to fundamentally reshape global technology competition. We're literally watching the fracture of globalization in real time. The age of one unified global technology market is ending. We're entering an age of competing ecosystems, competing standards, and competing platforms. That has massive implications for companies trying to serve both markets. Third, it means the price and availability of chips is going to become increasingly politicized. Right now, there's still one global chip market where everyone competes. But as these supply chains bifurcate, that's going to change. Pricing is going to diverge. Availability is going to diverge. Innovation trajectories might even diverge. You could end up in a world where cutting-edge chips are available in one region, but not another, depending on geopolitical alignment. Your device might literally have a different processor depending on where you buy it. And fourth, it means that the dream of Western technological superiority that's lasted for decades is fundamentally threatened. America has always assumed it would maintain technological dominance indefinitely. American companies like Intel, Qualcomm, Nvidia, these were just assumed to be permanently ahead, permanently superior, permanently dominant. But China is now in a position where they can not only catch up, but potentially overtake. And that's not some distant hypothetical. That's something that could happen in the next 5 to 10 years if current trends continue. Here's what's really interesting from a historical perspective. Sanctions are supposed to hurt the target. They're supposed to slow them down, weaken them, force compliance. But in this case, Western sanctions on Chinese chip technology might be the best thing that ever happened to China's semiconductor industry. They forced an entire nation to pour hundreds of billions of dollars into the problem. They forced the government to make it a national priority, higher than almost any other industrial goal. They forced companies to innovate faster than they ever would have otherwise. They attracted the world's best chip engineers to come work in China. They unified the country around a single goal, self-sufficiency. They created a sense of urgency and purpose that's almost impossible to match in normal competitive circumstances. You could argue that America accidentally created the conditions for China to leapfrog in semiconductor manufacturing. By trying to contain China, America forced China to build parallel capabilities that might actually be superior to anything America has. That's not just a strategic miscalculation. That's a potential reversal of technological supremacy. That's accidentally giving your competitor the motivation and resources to overtake you. And here's the thing about 35%. It's not just a number. It's a threshold. It's a psychological threshold that signals to investors, to companies, to governments around the world that China is serious, that this isn't just rhetoric or propaganda, that they're actually building a domestic semiconductor equipment industry that works, that they're delivering results. Once you hit 35%, you've proven viability, the next jumps become much easier. Companies see the market opportunity. The technology starts to mature, the supply chain starts to consolidate. Before you know it, you're at 50%, then 60%, then beyond. It's a momentum shift. What's also remarkable is that this is happening while China is still developing the most advanced technologies. They're not just copying old equipment. They're not just reverse engineering American products. They're innovating new approaches. They're solving problems in fundamentally different ways than Western companies solve them. Different methodologies, different philosophies, different engineering approaches. And that diversity of approaches actually strengthens the global semiconductor ecosystem in some ways, even if it means fracturing in others. Innovation comes from different perspectives, and China's engineers are bringing perspectives developed outside the Western ecosystem. They bring experiences from TSMC, from Samsung, from other manufacturers around the world. They bring insights from tackling the same problems that Western companies tackle, but from different angles. This diversity creates innovation. It creates competition that benefits everyone, at least in theory. Though in practice, the geopolitical competition might outweigh the benefits of technological diversity. The semiconductor industry has spent decades assuming that Western dominance was permanent, that the complexity of the technology created an insurmountable barrier to entry. But China just proved that assumption wrong. They've shown that with enough investment, enough talent, enough national will, you can build a competing ecosystem in just a few years. That's a lesson that's going to reverberate throughout global technology competition. It's going to change how nations approach strategic industries. For Western companies, this should be a wake-up call. Applied Materials, Lam Research, KLA, these companies were comfortable. They had market dominance. They had pricing power. They could charge whatever they wanted because customers had no alternatives. But now they're facing competition from countries that have essentially unlimited government backing. That's a different kind of competition. That's competition where market forces aren't the only thing that matters. That's competition where geopolitics and industrial policy trump normal business dynamics. It's competition they've never had to face before. For the semiconductor industry more broadly, this means the era of centralized global supply chains is over. The future is distributed. The future is multiple competing ecosystems. That has costs and benefits. It means redundancy, which creates inefficiency. But it also means resilience. It means that disruptions to one supply chain don't take down the entire industry. That's actually probably a good thing from a risk management perspective. There's value in having backup options. For China, this represents the culmination of a 20-year strategy to build domestic semiconductor capabilities. It's the payoff of enormous investment, strategic patience, and the willingness to pursue long-term goals even when progress seemed impossible. And it's working. It's actually working spectacularly. The strategy is paying off beyond even the most optimistic projections. The critical question now is what happens next. Do we continue on the current trajectory where China becomes increasingly self-sufficient, where global semiconductor supply chains fracture further, where geopolitics becomes even more central to technology competition? Or do governments and companies find ways to work together to avoid a full bifurcation of the global tech supply chain? My guess is that the genie is out of the bottle, the cat is out of the bag. China has definitively proven they can do this. There's no going back now. Pandora's box is open, and it's not closing. What's certain is that the chip industry will never look the same after this moment. The assumption of Western technological dominance, particularly in semiconductor equipment, is dead. China has killed it. Whether China surpasses the West or the two ecosystems coexist in a tense equilibrium, one thing is clear. American companies can no longer take their market position for granted. They're in a real race now. And China has surprised everyone, including their own government, with just how competitive they can be. The competition is real. The threat is tangible. The future is uncertain. This is one of the most significant technological and geopolitical stories of the decade. And most people have absolutely no idea it's happening. But it is, right now, today. As you're watching this video, decisions are being made in Beijing, in Seoul, in Taipei, in Washington that are going to reshape the global technology landscape. And it's going to reshape the world in ways we're only beginning to understand. That's what 35% chip equipment independence really means. It means the world just changed. It means the ground beneath our feet is shifting. The implications extend far beyond just semiconductors. If China can achieve independence in semiconductors faster than anyone predicted, what does that tell us about other strategic technologies? What about batteries? What about quantum computing? What about artificial intelligence chips? If the playbook works once, you can use it again. China's government has shown what's possible with sufficient funding, sufficient will, and sufficient focus on a single strategic objective. They can compress the innovation timeline. They can leapfrog over decades of gradual progress. They can make technologies that were supposed to be impossible actually happen in real time. The historical irony is profound. America thought it could control global technology through export restrictions. Instead, it created the conditions for its greatest competitor to develop alternative, potentially superior capabilities. The strategy backfired, and now we're living in the world that resulted from that miscalculation. We're living in the world where China is building its own semiconductor ecosystem, its own equipment industry, its own supply chain. We're living in the world where Western technological dominance is no longer guaranteed. We're living in the transition between one era of global technology and another, and it's happening faster than anyone thought possible. That's 35% chip equipment independence. That's the story nobody's talking about, but everybody should be.